In this video, we are simplifying expressions by collecting like terms. Before I show you the answer to the first example, I'm going to tell you one of the most common mistakes that students make on this type of question. The mistake will be where students add 5, 3 and 4 together because they can see those numbers. 5 plus 3 plus 4 is 12, and because there's an x in there, they'll just put an x on the end and say that the answer is 12x. As I said, that is completely wrong. I'm going to illustrate why that's wrong using tiles that I've got over on the side of my screen. The key point here is that you can't just add the 3x to the 5 and the 4 as if it was just worth 3. 3x is 3 multiplied by x, and x here is an unknown or a variable. We don't actually know exactly what it is, so we can't treat it as if x was just one whole. That's why I've got two different types of tile. I've got yellow tiles representing 1 and green tiles representing x. And the point is, x could be different, which is why the tile is a different size. So, to simplify 5 plus 3x plus 4, I can have 5 of these yellow tiles. 1, 2, 3, 4, 5. I then need to add 3x, so I need 3 of these green tiles. And then I need 4 of the yellow tiles. And the question is, what do I have all together? You can see that I can collect these yellow tiles together. And if I do that, you'll see that I've got 9 yellow tiles and I've still got 3 green tiles. And I'll write this as 9 plus 3x. Or I could write it the other way around. I've got 3x plus 9. Both would be correct. Let's have a look at the second example. I've now got 5 plus 3x plus 4x. Now, I can collect the 3x and the 4x together, but I can't collect the 5 with those. Let's see why. The 5 is represented by 5 yellow tiles, just like before. The 3x is represented by 3 green tiles, just like before. But now I'm adding 4x instead of 4, so I need 4 more green tiles. And you can now see that altogether I have 5 plus 7x. Or I could write that as 7x plus 5. The key point here is that you can do this without needing these tiles. You just have to identify what the like terms are. So in example B, the 3x and the 4x are like terms. I can collect those together to give me 7x. In the first question, the 5 and the 4 were like terms. 5 plus 4 gave me 9. Here's the next example. We've got 5 plus x plus 4x. Again, I've got 5 yellow tiles. 1, 2, 3, 4, 5. I've then got to add an x, so that's 1 green tile. And then I've got to add 4x, so that's 4 green tiles. You can see here that I've got 5 plus 5x. Now, if you wanted to do this without the tiles, it would help to realise that the x is actually the same as 1x. There's an invisible 1 in front of that x. We normally don't bother writing it. We understand that x means one lot of x. But if that 1 was in there, you could see a bit more clearly why 1x plus 4x gives you the 5x that we need in the answer. Before we continue with the other examples, we need to recap something really important about addition, subtraction, and negative numbers. The big idea is that any subtraction can be rewritten as an addition, and addition is normally a good way of thinking about things. Let me give you an example. 7 minus 4 is 3. That's a subtraction. Now, instead of subtracting 4, what I could do is rewrite that as 7 plus negative 4. That's still equal to 3. It's the same calculation, but I've rewritten the subtraction as an addition. And in general, if you are subtracting a quantity, it is the same as if you were adding the additive inverse. Basically, the same quantity, but with the opposite sign. So, as another example, if I had 8 minus 17, it's the same as 8 plus negative 17. Now, just one more key idea here. If I have some tiles like this, you can see that what I've got at the moment is worth 3. If I wanted to do 3 minus 5, I could think of that as 3 plus negative 5. So I could just add 5 of these red tiles to what I've got. I had 3 and I've added negative 5. Now, what is this worth altogether? Well, here's a big idea. If I pair up a 1 and a negative 1, they're worth 0. So there's another 0 pair and there's another 0 pair. A 1 and a negative 1 put together is worth 0. So once we get rid of all of those zeros, what we're actually left with is just negative 2. Here is example D. 5 plus x minus 4x is equivalent to 5 plus x plus negative 4x. I can represent that using these tiles. I've got 1, 2, 3, 4, 5 plus x, so I need to add on one of these green tiles, that's plus 1x, and then I need to add negative 4x, so that's adding 4 lots of negative x. 1, 2, 3, 4. Now, we can collect the x terms together, and in fact, we have a 0 pair amongst them. If I put that x and that negative x together, they are worth 0. So what I am left with is simply 5 plus negative 3x. And we can write that as negative 3x plus 5. Because remember, when you're adding two quantities together, it doesn't matter which way round you write them. Or we could have rewritten that original one as 5 minus 3x. All three of these are correct answers to this question. They are all simplifications. We have collected the like terms, the x term and the minus 4x term. Collecting them together gives us the negative 3x that we see in whichever way we write our answer. In example E, we've got 9 plus 5x minus 3 plus 2x. Let's try doing this without the tiles. We've got two pairs of like terms here. The 9 and the minus 3 combined together. We can collect those to give us 6. And then we've got the plus 5x plus 2x that combine to give us plus 7x. Let's see that with the tiles. 9 looks like this. plus 5x looks like this. Minus 3. Now that's the same as adding negative 3. So I'm going to add negative 1, negative 2, negative 3 in total there. And then finally I'm adding 2x. So I need to add x and another x. And we need to find any 0 pairs. We've got one there, and one there. So they all vanish. And we're left with 6 plus 7x. And of course, we can write that as 7x plus 6. Here's the next one. Pause the video and have a go at this for yourself. What you should have noticed is that in here there's an invisible 1. So this is really 9 plus negative 1x plus 5x plus 2x. And you can collect those 3x terms together. They are like terms. And the 9 is on its own. It doesn't combine with any other terms. So what we end up with is 9 plus 6x. The negative 1x plus 5x plus 2x give us 6x. Here's the next one. Pause the video and have a go at this for yourself. Okay, we're going to do this without using any tiles. We've got negative 9. That doesn't collect with any of the terms, so that means our simplified answer is going to contain that negative 9. Then we've got a negative 1x plus 5x plus 2x, just like in the previous example. And that gives us plus 6x. So the answer here is negative 9 plus 6x. Or we could rewrite that as 6x plus negative 9, which we can write more simply as 6x minus 9. All three of these answers are perfectly correct. And here's the last question. Pause the video and have a go at this one for yourself. In this one, the negative 9 and the 2, those combine. We can collect those to give us negative 7. And then the other terms, the negative 11x and the positive 5x, they combine to give us negative 6x. So here we have negative 7 plus negative 6x, which is the same as negative 7 minus 6x. We could also write those the other way around.